Hello everybody. In this video I will talk to you about normal distribution and the basic idea behind the whole concept. Also how to apply your calculator to solve application problems. Okay, so what is a normal distribution? It is a distribution that's used to model data that's bell-shaped, right? So we've kind of briefly looked at bell-shaped data in chapter 3. And what does this data look like? It's symmetric about the mean, and we also applied the empirical rule. If you recall, this rule said that 68% of the data lives within 1 standard deviations of the mean, and then 95 within 2, and 99.7 or almost all of it lives within 3 standard deviations of the mean. Okay, but after learning this material, we will be able to say a lot more about normal distribution. So what is so special about normal distribution? Almost all of the inferential statistics is based on normal distributions, so we should definitely try to understand this concept really well. Okay, so when it comes to normal distribution, what you should know is the following. The area under the curve of the distribution, so if you were to look at the area under this curve and you were to compute this, and you would use that by integrating a function. Okay, don't worry, you're not going to need to use that. Okay, the area under the curve is equal to 1. And that's why we can use this as the probability density function. Okay, because for probability density function, what do we have to have? That the sum of all possible outcomes needs to be 1. So think about this as 100% of all of your observations. Okay, and then what else do we need to know about the normal? That it has 2 parameters. And they are the mean and the standard deviations, and then they will vary from problem to problem. But we're going to start with a very particular case, what we're going to call a standard normal. So standard normal distribution. Standard normal distribution is, the notation will write it as this: n 0 1. This means that the mean is equal to 0 and standard deviation is equal to 1. Okay, so if I were to make a picture to represent this, okay, so let's see, I would have my bell-shaped curve. Mean is 0, so 0 would sit right here. Okay, and according to my empirical rule, if I go 3 standard deviations to the right and to the left, I'm going to cover almost all of the data, right? So if I were to mark these points, this would be 1, 2, 3, -1, -2, -3, and that would be 99.7% of all my data. Okay, but now we can say a lot more. We're no longer limited to these marks that mark standard deviations. We can answer this question right here. What is the data, or how much data is located between these 2 points? Okay, what if I wanted to compute this piece right here? We will be able to do it. So let's go ahead and practice some calculator skills. Okay, let's do the following. This one says shade in the given area and then compute the area under the curve. So let's say the first problem says, here's your curve, shade in the area to the left of z is equal to 0.88. Okay, now what does that mean? Well, remember, that your mean for standard normal, so all of these problems are for standard normal distribution, it's 0 right here. Okay, now z means what? Think about this as z is equal to x, so that's the x value. The reason why we do z, because that's actually a z-score, right? So if we were to compute the value is x, 0.88, so if you were to compute the z-score for this particular case, you would do 0.88 minus 0 over 1, but that's just 0.88, right? And it's true because we're dealing with standard normal. So z in this case represents the distance from the mean, and it's which is 0. So 0.88, where would that be located? Well, let's see. If 1 is somewhere here, right? So let me see. If 1 is somewhere here, then 0.88 would be roughly here. Okay? So here's my 0.88. So this one says shade in the given area and then compute the area under the curve. To the left of z is equal to 0.88. So let me shade that in. That would be this piece right here. Okay, let's go ahead and make a prediction how much we should get. Now remember what, before we compute anything, right? Let's kind of apply the empirical rule. So what is this piece right here? Just this piece to the right of 0. That should be 50%, right? And then, so you say, okay, approximately, how much should I get? 50% plus. What about this one right here? According to our empirical rule, this one was 34%. So slightly less than 34, right? So something less than 34%. Okay, so we can kind of estimate it and say, how much should we get? We should get something around 80%, anywhere between 80 and 82. So let's go ahead and make some guess. Let's say 82%. Okay, that's our guess. This is our guess. An educational guess, right? It is based on something, and it's based on the empirical rule. Okay, now your calculator will be able to compute that exactly. So the command that we're going to use to compute this is going to be normal CDF. Okay, and there's a syntax that goes with this command. So we gotta tell the calculator what is our lower limit. Low limit. How far to the left am I gonna go? Then high limit. How far to the right am I gonna go? And then the next two will be mean and standard deviation. Okay, so let's see. How far to the left do I need to go? Well, I need to go, actually, technically, infinitely to the left, right? Because I want to make sure I cover all of it. So think about this as a negative small number, right? So this would be negative, it goes to close to negative infinity. So negative number. Okay, and there's a way to plug this in. And I'm gonna go up to 0.88. So how would I plug this into my calculator? So let's go ahead and do it. This would be normal CDF. Okay, you can do it a couple of different ways. So the book is teaching you to do negative 1 e to 99, and then up to 88. Mean is 0 and standard deviation is 1. You can do it this way, okay? But sometimes you type in a wrong e for 99, and I'll show you what the difference is. So what I recommend doing is say normal CDF and just plug in a large number that's negative. Okay, so large in absolute value and then negative all the way to 0.8801. So let's go ahead and plug this in. Okay, so now you have your calculator. Let me go ahead and turn that on. We're gonna go to second variables. Okay, and it's your second command. You do not want to use PDF. That one is used when we want to graph normal. We don't want to graph it. We want to compute the area to the left. Okay, so now I'm gonna plug in negative. And what did I do? I said 10,000. Okay, up to 0.88. My mean is 0. Standard deviation is 1. Okay, remember we had an educated guess that it should be around 80 something percent. There you go. It's 81, roughly 81%, right? So then you say, what is your answer for this part? This one would be 0.81. Let's do 4 decimal places. 0.8106. 8106. You want to write it in percentages. That's 81.06%. And that is really close to our guess. Okay, so that's how you find the area to the left. So let me show you how you plug in that E. Okay, so let's go ahead and go back to second variables, command 2. How to do E? It is not the exponential E. It is this E right here. So you would have to do negative and then second E 99. Okay, not this E right here. Okay, because this will give you a wrong answer. And then we're gonna do up to 0.8801. Close the parentheses. And look, you get exactly the same thing. Okay, but it's so much quicker for me to just plug in a whole bunch of zeros, right? So negative 10,000, that's easier than plug in negative E99. It doesn't matter how you guys gonna do it, you really will get the same answer. So there you have it. Okay, but if you're gonna use E, make sure you use the correct E, not the base of the natural log, a different type of E, the one that says second comma. That's what you will be using. Okay, all right, let's take a look at a couple more examples. What if you had to find the area to the right? So let's say this one was first part. The second part says, let's do area to the right of Z is equal to 0.46. How would I do that? Well, let's go ahead and make a picture. Okay, so still we're dealing with standard normal. Here's your 0. 0.46, it's somewhere here, right? To the right would be this area right here. Okay. All right, same command as before. Normal CDF. Okay, what's my low limit? What's my lower bound? It's 0.46. What's my upper limit? Again, I'm going up to infinity to the right. So I can do e to the 99, positive e to the 99, or I can just plug in a really large number. So let's do 10,000. Then mean is 0. Standard deviation is 1. Okay. So let's go ahead and do that. Okay. We're going to go to second variables, command 2, 0.46 up to a large number. No, I need to use comma. 0, 1. Okay, that gives us, how much does it give us? 0.3228. 3228. Okay. So that would be this area right here is 0.3228. All right. Okay. What if you were asked a question to shade in the area between two values? So let's say between z is equal to negative 1.5 and z is equal to 2.5. Okay, let's make a picture. Oop. Okay, so let's see. Oh, what's going on with this pen? Okay, so here's my 0. Negative 1.5, so it would be roughly over here, right? Negative 1.5. 2.5 standard deviations away, so that would be somewhere here. Okay, this is just a sketch to give you an idea how much you should be covering. So we're gonna shade in this area. We're going to use the same command, normal CDF. Okay, we go from negative 1.5 up to 2.5 for our z-scores. Mean is 0, standard deviation is 1. Let's go ahead and compute it. So we go second variables, plug in these values, so negative 1.5 up to 2.5, 0, 1. And we get almost all of it, and it's not surprising. So 0.927, right? So let's do 0.927. Okay, that would be your answer here. All right, so that's the first command that you should know how to use on your calculator. And again, the order matters, how you're going to plug it in. So the low bound, the high bound, then the mean, and then the standard deviation. You can't switch them out. They have to come in this order. Okay, and the second command that we need to use is going to be the inverse normal. So let's talk about that. What if you are given the area and you want to find the z-score that corresponds to it? Okay, so for example, this one will say find the z-scores for which, and we have a couple of different scenarios. So the first one will say the area to its right, it's 0.75. Okay, so let me write this out. The area to its right is 0.75. Okay. All right, so I would always try to make a picture for this type of situation. Okay, let's see what we know for sure. We know for sure that if we have 0, then the area to the right of 0 is 50%, right? So that would be 0.5. So if I need 0.75, that means my score will be sitting right here. Okay, so I know this will be a negative score because this area will be 0.75. Okay, and I know that I will get a negative z-score. Now, the way your calculator is set up, when your calculator is set up to find those z-scores, what you need to know is that you need to plug in the area to its left. Okay, so that's just how the syntax works. Okay, you need to plug in the area to the left of that score that you're trying to find. Well, if this is 0.75, then this one would be 0.25. Okay, and the command that we will be using, it's called inverse normal. And what it's doing, it's returning the z-score. So these values right here, it's gonna find that cutoff value that cuts your distribution, 25% on the left and 75% on the right. Okay, so the idea here is you plug in the area to the left, then followed by mean and standard deviation. So for our problem, you would do inverse normal. Area to its left is 0.25, mean is 0, and standard deviation is 1. Okay? So let's go ahead and do that. So we're going to go back to the same place. This would be second variables, and it's command 3. Okay, and now we do 0.25 area to its left, 0, 1. Enter. Huh? What happened? Okay, so let's delete this space here. And there you go. So negative 0.6745. Okay. Negative 0.6745. That would be the score. Okay. You can always check this. How would you check it? What if you do normal CDF and just do this, negative 0.6745, 10,000, 01. Okay, so you find in the area to the left of this one right here, you should roughly get 75%, right? Because even though we're approximating it, so we rounded it to 4 decimal places, we should get 75% of 0.75. So let's go ahead and check this real quick. Okay, so let's go back to second variables. We'll do normal CDF. We'll plug in negative 0.6745 up to 10,000, 01, and there you go. Okay, that doesn't contradict, and it actually reaffirms that our computation was done correctly. Okay, so that's how you find the z-scores if you're given the area to its right. Okay, what if you're given the area to its left? So let's say a second problem says find the z-score where the area to its left is 0.32. So the area to its left is 0.32. How do we do that? Okay, so let me go back here. Oops, too far. Okay, let me go ahead and make a picture. The area to its left is 0.32, so I know it should be somewhere here, right? Again, this is just a rough sketch. So 0.32, it's less than 1/2. So if this is 0.32, then the rest should be what? 0.68. Okay, we'll find in this area right here. Okay. And if it's given to you as is the area to its left, then you just plug that in. You just plug that number right there. So normal CDF 0.3201. And you know that it's going to give you a negative number, and that's fine because this z-score should be negative, right? It's to the left of 0. So let's go ahead and do that. I'm going to go to second variables. Command 3, 0.3201, and we get negative 0.4677. Okay. Alright, so then the only other thing that we have left is, what if we are asked to find z-scores that bound some middle percentage. So let's say you have the following: z-scores that bound middle 64%. Okay, how do we do this? All right, this one is the only one that's a little tricky, but once you get the idea, it's kind of easy. Okay, so middle 64%, what does that mean? It means these are my 64%, right? Okay, you just make a quick sketch. So middle 64% over here. That's my middle 64%. Now remember, the command is set up in such a way that you need to find the area to the left of z-score. So if I were to find the area to the left of this score right here, okay, so if I were to find this score right here, because it's symmetric, then this score will be the same as this one, except this one will be negative and this one will be positive. Okay, so how do I find the area that I just shaded with purple? Well, the whole thing is 100%. If I do 100 and minus 64, that would give me how much? That would give me 36, right? Okay, but that's 36 for this piece and this piece. So if I do 36 divided by 2, which will be what? 18, that would be my area over here. 18% and 18%. Okay, so that means if I plug in 0.18, I should be able to find this z-score right here. So let's go ahead and set up the computation. So what would I do? I do inverse normal 0.18 0.1. That will give me a negative z-score, which is fine because then I just take the positive, and that's going to be the z-scores that bound the middle 64%. So let's go ahead and find that value. So we go back to second variables, 0.18 0.1. That gives us negative 0.9154. Okay, negative 0.9154. Okay, let's go ahead and check. So how would I check this? If I were to do normal CDF and do negative 0.9154, positive 0.915401, okay, then I would be finding this area right here, right? So if I found it correctly, this should give me 64%. Well, let's see if it does. Okay, we're gonna go back to second variables, command 2, negative 0.9154, 0.9154, 0, 1. It is 64%. Okay, of course it's a little off here because you rounded your numbers to begin with. Okay, so the more accurately you plug them in, then the more accurate result you're gonna get for your normal CDF answer. But this gives you an idea, oh yeah, I did it right. Okay, so that's a good way to check if you found your Z-scores correctly. Okay, all right, I think I'll stop right here. In the next video, I will solve an application problem, an actual word problem with the normal distribution. Thank you for watching.